This is an overview of HotPixels, a tool for denoising and correcting hot pixels in long exposure images. Let's start in Lightroom. I took this panorama of a night landscape foreground using 4-minute exposures. When I zoom in, you can see red, green, and blue blobs all over. And if I look at the other frames in this panorama, looking at the lower right corner, you'll see this pattern is pretty consistent. These are hot pixels from my camera's sensor. They typically happen during long exposures when the photodiodes on the sensor are exposed to heat, causing them to give erroneous high values that we see as bright pixels. Now, there are some different ways we can deal with hot pixels in camera or in post-processing, but I'm going to focus this video on a specific technique. On the night that I took this panorama, I also took a series of dark frame images with the lens cap on. And looking at them now, I can see the same hot pixels. I'm going to select all of these dark frames and pull them into the HotPixels tool to generate a profile from dark images. This opens up the HotPixels tool and does some analysis on these frames. A few interesting things to note. We analyzed 8 dark frame images. Remember, we shot these with the lens cap on, so we expect all of the pixels to have the same value. But we found about 24,000 pixels that deviated significantly from the average pixel value. This sounds like a lot, but it's a small fraction on this 24 megapixel sensor. Also notice the hot pixels are not perfectly consistent among the frames. About 9% of the hot pixels on any frame were not common with the other frames. So when we're taking real photos, we should expect there to be random hot pixels also. The bar charts here are mostly a sanity check. We expect the hot pixel count and average values to be consistent among the dark frames that we used. Finally, there's a temperature plot. Some of the methods that we use to denoise and correct hot pixels are sensitive to temperature. Let's save this profile, which adds it to my library. I took these dark frames on the same night as the photos I want to correct, and that's ideal, but you can reuse profiles when they have similar shutter speed, ISO, and sensor temperature to your target images. Let's exit and go back to Lightroom. Back in Lightroom, I'm selecting the images that I want to correct. Then I'm going to correct images with hot pixels. Now we're back in the hot pixels tool, and this time we're on the correct images tab. The app automatically found the best matching dark frame profile from our library, and it's also showing us the raw image. This is really what the raw image looks like coming off of our camera's sensor. Kind of a grayscale checkerboard pattern. We can also look at the processed RGB image. And let's look at some hot pixels to talk about why we're working with raw images. Notice that in the raw image, we have some sparse individual hot pixels. And when I switch to the processed RGB image, these turn into larger blobs. This is an artifact of the demosaic process that colorizes a raw image. On CMOS sensors, there's a grid of photodiodes, and above each photodiode, there is a red, green, or blue color filter. So each pixel in the raw image only contains color information about red, green, or blue. When we load a raw image on our computer, the detailed color in the photo is interpolated from these color brightness values. That means that the color in each pixel in our photo is determined by looking at the neighboring pixels to determine how much red, green, or blue should be present. So for example, we have this pair of hot pixels here that if we look at the RGB image, we know are blue. And when the image is processed, the color of all of the pixels in this region is influenced by this bad data in these hot pixels. Fixing this blue blob in Lightroom or Photoshop requires changing 20 or so pixels, but if we can fix this issue in the raw data, we only have to fix 2 pixels, so the impact on the final image is much less destructive. Now let's talk about the corrections we can perform. When we created this profile, we analyzed 8 dark frame images, and we have a map of pixels that are consistently showing high values, but we need to deal with them in 2 different ways. If the deviation is low, These are probably not the hot pixels we've been looking at, but they can still be a source of noise. For these pixels, we'll subtract the difference between the pixel's value and the mean value for the dark frame. If the deviation is high, it's a hot pixel, and we'll treat this as bad data and interpolate a new value from this pixel's neighbors. Let's apply these two corrections and look at the result. Toggling corrections on and off, we can see this did a good job removing most hot pixels, but there are still some residual hot pixels remaining. Remember when we generated this profile, a fraction of hot pixels in our dark frames were random? If we want to remove random hot pixels, we can't use the information from our dark frames. So this last method, remove residual hot pixels, uses a neural network to try to identify hot pixels that we didn't find using any other methods. The first time we enable it for an image, it's going to take some time. Similar to AI denoise in Lightroom or Photoshop, it runs a lot faster on a discrete GPU or Apple's performance shaders. Okay, that looked like that did a pretty good job. Let's turn it off and on again. It really looks like that addressed most of our remaining hot pixels, so I'm pretty happy with that. Once we're happy with the results for this image, we can batch process the rest of the images and then go back to Lightroom. Finally, back in Lightroom, we can compare our original and corrected images. We have our original here and the corrected DNG image here. Let's look at them side by side. And we have our corrected image now on the left and the original image on the right. And you can see it did a pretty good job removing all of those hot pixels. The corrected image is a RAW DNG file, so if we made any edits, they'll be visible on the Develop tab. If we want to use features like AI denoise, we can still use those too. That's it for this walkthrough. If you're interested in this project, you can find more details on GitHub.